Dear students, we'll see ARM processor architecture today. So why ARM? What is ARM? We recollect once again. Reduced instruction set computing architecture. Right? So it is, I already told you that it's a load and store type architecture where the data processing is performed only on the content of the register rather than directly on the memory. It is a 32-bit ARM processor, have a two instruction set. One is general 32-bit ARM instruction set, another one is 16-bit ARM instruction set. This ARM supports the multiple stage of pipeline to speed up of the flow of the instructions. So the architecture, the profile, when you talk about this architecture profile ARM, this mainly it is used for the application purpose, and we are using this real time, and we are using the heart of this IoT is a microcontroller. So when you talk about the application, it is high performance and designed to run a complex operating system like a Linux or Windows, and it is mainly targeted for the real time requirements. So it is mainly used in networking equipment and the embedded control systems. So this microcontroller is the heart of this IoT. Any IoT device, the microcontroller is the heart of the systems. It is very small, but the performance wise, it is very high and efficient devices. Now we'll see the ARM data flow diagram. So this is the ARM architecture. How the data is flowing, we'll see one by one. So here the data are stored in the memories, right? The data are in a, it will have an address for this data. Okay. Now we have to fetch the data from the memory. Then that fetching instruction is passed on to this instruction decoder, and the instruction decoder will tell that what are the operations. Here we can see here the sign extent is here, given here. So what is the meaning for the sign extension is, so the data may be, the opcode data may be a 16-bit or 8-bit or 32-bit. So if it is a 16-bit, 8-bit, we have to extend it. Why we have to extend it to 32-bit? Because the registered files are 32-bit files. Okay, so we have to extend this 8-bit or 16-bit to 32-bit. Okay, that is the use of this sign extended. Okay, so the sign extended the data may be a 32-bit. So if it is a 32-bit, it will need not worry about this extension. So it will directly go to the register file. Here the sign extension means, here how it will extended means, before the data it will add zeros. So in that way it will extend it to 32 bits. Okay, here you can see the register files from R0 to R15. Here the R15 used as a PC, that is program counter. Okay, then you can see here there are two operand, A operand and B operand. So that both operand will pass on to this, both operand to enter into this ALU. What is ALU? Arithmetic logic units. So the operand B, it will move pass on through this parallel shifter. Okay, so if this shift is required, then we can shift this data. Otherwise, it directly go to the ALU, arithmetic logic units. So here you can see here the barrel shifter. What is this barrel shifter? It is a combination logic shifter. That's all. Okay, here the barrel shifter will use as a prescaler. What is this prescaler of operand? What is this prescaler operand? So suppose let us consider 0, 0, 0, 0, 1, 1, 0. That means 1 minute. 0, 0, 0, 0, 0, 1, 1, 0. What is this? This is nothing but 0, 6. Correct? So now I am shifting leftward 1 bit, 1 bit. Then you will get 0, 0, 0, 0, 1, 1, 0. That 0, this 0 will come this side. So it will become, now it is, you can see, this is 8 plus 4, 12. So it is 12. That means we are multiplying them by shifting 1 bit left. We are getting a multiplication of the 2. That is 6 into 12. So when you shift again, you will get here. If you get this one, right, 1, 1, 0, 0. What is this? Here 1, 0, 0. Right? Here 8 plus 8. Sorry. 16 plus 8 is 24. You will get 24. Okay. In that way we can use this parallel shifter as a prescaler, right? The next one is the MAC. What is this MAC? Multiplier accumulator. So multiplier accumulator, you can see here the operands A operand and B operand come here and accumulated is let us consider the example here. MLA, okay, MLA R0, comma R1, comma R2, comma R3. So what is this? How the MAC operation will perform here? Here, that is, this is R1. Okay, here how the MAC operation will perform here. You can see that is here R1, R2s are multiplied and added with this R3, that will stored in the R0. Okay, so I can write this as a R0 is equal to R1 plus into R2 plus R3. Okay, so that is stored in the, that result is stored in the registers again. Here you can see the results are stored in the register here. Again in the stored in the register file. Okay, so you can see here all these arithmetic logic unit results are again stored in the registers. Okay, here the PC program R15 act as a PC program counters. So once it is on the operand, so once the address registers, once the data is fetched, again it will go, it will increment this memory addresses. Okay, this is the data flow of this ARM processor. Here this ARM processor have address bus are 32-bit address bus, and it is von Neumann model, because here we are using only one memory for code and data, and here the data bus are 32-bit bus and AL is a 32-bit bus. Here we are using the parallel shifter for shifting purpose, or we can use it as a prescalers, and the MAC is multiple accumulators. Okay, so multiple accumulator, so both multiplication and you can addition operation we can perform in this MAC. The incrementer, the program counter will increment the address registers. Okay, so we can all the results are stored in the register file itself. So this is a complete architecture with the instruction code and control logic. I told you already, it's a 32-bit arithmetic logic unit, and it will have a register bank, and a multiplier is there, and parallel shifter is there, and A bus, B bus, operand A and operand B bus. These are the instruction decoder and the control logic. So this ARM processor has 37 registers. In that 30 registers are general purpose registers. All the registers are 32-bit long. Okay, that's why we are using this. Suppose if it is a 16-bit or 8-bit, we are using the sign extended for making it into a 32-bit address, 32-bit long. Okay, and it also has a program counter, CPSR, SPSR. What is CPSR? It's a program status register. PSR is a program status register. It has a CPSR, it's nothing but current PSR, current program status register, and also it is having SPSR. 5 SPSR is having it. The 5 SPSR. What is the SPSR? SPSR is save program state register, status register. Suppose if we have many models, suppose it is want to do some model 2, then the model 1 register is stored in the save register, save program status register. Okay, so and I told you that this program ARM has a 30 general purpose register. The processor mode decided which bank is accessible. Okay, so that's all about this ARM architecture and registers. Thank you.